Hello wonderful person, this is Anton, and today we're going to once again discuss a very unusual type of a galaxy that only recently started to be discovered and whose origin and exact properties were more or less unknown until some of these recent studies. And here we're talking about a subset of galaxies referred to as winged radio galaxies, or basically galaxies that look like they have wings, and galaxies whose morphology is not that easy to explain. But in this case, these galaxies can only be seen with radio telescopes and actually look entirely different in optical light or in other wavelengths. And though for our eyes or for optical telescopes, these galaxies would form familiar shapes such as spirals or elliptical shapes, when we switch to radio waves, these galaxies, and technically the entire universe, transforms completely. And we'll actually discuss some of these observations in one of the recent videos because the radio collaboration known as LOFAR has recently created the largest radio map of the entire universe. The map containing millions of different structures, including, of course, these newly discovered winged formations. But astronomers didn't actually expect to find this, because they actually thought they'll find something that resembles this. Massive jets of plasma blasting from centers of galaxies, stretching millions of light years. And this is of course what we usually see because these are formations created by central black holes. And some of them are so big, they form some of the largest structures in the universe. This is Alcyoneus, a giant radio galaxy 16 million light years across. You can learn about Alcyoneus in one of the previous videos in the description. And so for a very long time, most of these radio galaxies followed a standard pattern, two giant lobes of gas on either side of the galaxy, with many similar shapes discovered all over the place. As a matter of fact, this one is probably the most famous of them all, and is also the closest to us, the galaxy known as Centaurus A, whose radio lobes have been studied for a very long time, but that naturally looks very different in the optical light. But in the last few years, astronomers have also found a somewhat rare type of a radio galaxy that was basically a kind of a strange subset, winged radio galaxies. Here's actually one of the most famous ones discovered a few years back. And these galaxies don't just have two lobes, they seem to have a kind of an extra pair, or a fainter low brightness lobe that sometimes resembles wings. And it actually gives them a distinct X or even Z shape, which is what these galaxies are now referred to as, X-shaped or Z-shaped galaxies. But until very recently, these were considered to be super rare, and were also a kind of a cosmic enigma because nobody actually knew exactly how these shapes form. But today we're going to discuss this recent study, a study by Suman Kumar released in May of 2026, which has just expanded this cosmic class by over 1,000 new discoveries. Many of them containing even stranger shapes, and many of them forming something that's super difficult to explain. Although obviously there are some explanations. But to try to understand exactly how this forms, or what this even is, we first have to briefly discuss radio galaxies and how they normally form their jets. And so here we need to first discuss the basics. And that's because a radio galaxy is always some kind of an active galaxy that's just incredibly luminous in radio wavelengths. And this is of course the result of the active supermassive black hole right inside the core. We call these active galactic nuclei, or AGN. And so as the black hole feeds on the surrounding gas and the surrounding dust, normally it produces two opposite jets. But as these jets travel, they sometimes hit a lot of thin gas between galaxies, especially if this is happening inside a galactic cluster, which contains a lot of gas between galaxies, which then causes the jets to slow down, spread out, and form these giant lobes that start to emit synchrotron radiation from the interaction of electrons. And this is what produces these radio emissions. And so basically the change in velocity and acceleration of these jets starts to produce these radio signals. But here we pretty much always expect a double lobe structure, or basically two jets, with this once again being a kind of a stereotype. And so how exactly would you get a winged radio galaxy? So essentially, how would something like this form? And so this represents a fascinating deviation from classical symmetry. But for many decades, we've only known of a handful, and even there they were quite different and were believed to be produced by different phenomena. But this new discovery, conducted using a massive search using the data from LOFAR, has now officially confirmed over 1,000 more. And this was actually only discovered because this telescope looked at very low frequencies, which were previously invisible to us because other telescopes focused on different wavelengths. And this was important because these wings seem to represent much older, or I guess much more aged plasma that just does not glow as brightly and does not produce higher frequencies. And so this is only visible to much more sensitive telescopes and telescopes able to see much longer wavelengths. And so here, by scanning a dataset of 4.3 million radio sources, this is of course that map we've discussed in the previous video, and also by focusing on structures that were larger than the galaxy, specifically larger than 20 arcseconds in the night skies, they were able to confirm 200,000 initial candidates. And out of all of these candidates, 621 were confirmed to be wing galaxies, and 403 were confirmed to be possible wing radio galaxy candidates. With this study effectively confirming that this is not a rare subclass of galaxies, but instead seems to be a more or less common phenomenon, because quite a few of them seem to exist out there. And because so many have been discovered, researchers could now definitively divide them into two additional subclasses: the X-shaped radio galaxies, or XRGs, and the Z-shaped ZRGs. And so for the X-shaped, like the ones you see right here, wings seem to emerge directly from the center of the galaxy, with at least 380 of these discovered in this study. This is most likely formed by some kind of a different phenomenon from the Z-shape. And the Z-shaped radio galaxies seem to contain wings that branch off from the outer edges of the primary lobe, creating a kind of a Z or S shape, as if the jets bounced off and went in a separate direction. 239 of these were found. And so basically, both types seem to be pretty common, but seem to form from a different phenomenon. As a matter of fact, the X-shaped galaxies seem to have much steeper spectral indices compared to the Z-shaped galaxies. In simple terms, this means that the X-shaped galaxies are likely made out of plasma that's much older and much more diffuse, whereas the Z-shapes are younger and the plasma is a lot more compact. But the obvious question is, of course, okay, so what exactly is this and how is it formed? So how does such a galaxy get its wings? Well, right now there is no one answer, but there are possibly several explanations. And actually, three main explanations based on this study. The first explanation involves a backflow model. This is the most widely accepted explanation for the X-shaped galaxies. It suggests that as the jet travels outwards, the plasma eventually hits a wall of some kind of a dense intergalactic gas and is then deflected back toward the center. And so if the galaxy is shaped like an oval or an elliptical galaxy, the plasma just follows the path of least resistance, normally along some kind of a shorter axis, which eventually results in these wings. So essentially jet in this case bounces off something and spreads back into the galaxy. Then we have the second explanation referred to as the spin flip or jet reorientation model. And here this suggests that the wings are actually a kind of a relic from a past event. And specifically, if the two galaxies merge, their supermassive black holes will eventually collide and merge as well. And this violent collision can suddenly flip the axis of the black hole spin, causing the jets to point in a completely new direction. And so the wings we see are just the fading remnants of the old jets, while the primary lobes are the new jets. So basically we had two jets before, galaxies collided, now we have two new jets. And lastly, the third explanation is a little bit simpler. Maybe there are just two central black holes. Or essentially, it's possible that some of these galaxies host two active black holes, each shooting its own pair of jets in different directions. But exactly which explanation applies to which galaxy is of course unknown. As a matter of fact, so far, none of these explanations seem to explain any of these galaxies too well. But in general, this definitely tells us a lot more about the violent history of galaxies and their black holes, and thus suggests that quite a lot of galaxies out there seem to go through some kind of a major event that completely changes the jets. With this study also discovering that at least 16% of these galaxies also qualify as giants, or basically in terms of the linear size from end to end, a lot of them seem to be over 2.2 million light years across. that's approximately 20 times larger than the Milky Way galaxy, with one candidate, a galaxy J1155 plus 4029, measuring at nearly 6 million light-years, one of the largest radio galaxies discovered. And while finding so many giants suggests that the mechanism triggering the formation of these wings might also be responsible for making these galaxies grow so ridiculously large. In other words, whatever is happening here seems to be directly connected, and also helps us understand how many of these black holes pump energy back into the environment, which for many galaxies stops star formation and makes them almost entirely dead, eventually making them become somewhat red in color. But naturally, this is just the first step because radio astronomy is only getting better and better, with the researchers now planning a follow-up, especially because they want to capture these galaxies in both optical and infrared light in order to find out how the host galaxy reacts to these formations and changes over time. Because for many of these wing galaxies, only radio image exists for now. And so by comparing radio observations with the infrared and optical measurements, it might help scientists to figure out exactly how this forms, because they might contain, for example, signs of mergers or even binary black holes. But anyway, at least for now, this is just one of the latest unusual discoveries from the rest of the universe. These very strange winged cosmic structures. And it's also a reminder that the more sensitive the telescopes become, the more we realize the universe is actually much more unusual than we thought. On that note, once we find out more, we'll come back and discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.